Alright, so now that you have an understanding of the different sets that mathematicians use, let's see how they use it to describe things such as domain and range. So here we have what we call set builder notation. This is a notation that tells us what element, what set, and what condition must be satisfied for this set. So here in yellow we have the element. The element refers to what number is being referenced in the set. For instance, x could reference the domain of a function. This E sign that's curved here, that stands for element of, so x is an element of. Here in blue we have the real numbers. This is the set we're describing. So in this case we're describing all real numbers. That's what x is an element of. We have a slash, which means this is our condition. Behind it, we have this condition, which is x is greater than or equal to 0. So basically, x has to be a real number, but it also must be greater than or equal to 0. Now, I said that this x could be the domain, for instance, of this set. So a possible function for this could be square root of x, right? Because x must be greater than or equal to 0, and anything greater than and equal to 0, such as all the positive real numbers, they all satisfy this. Now let's take a look at this bottom set. So now we have y instead of x, so this could possibly mean the range of the function instead is the element of the real numbers, given that x is not equal to 0. Now you may not know this, but a possible function that has this range is 1 over x. The reason being is if the range here, if you take any x in here, all of the y's that come out of it, you'll never be able to get 0, because if you try solving 1 over x equals 0, you get 1 equals 0. As I'll show you here, you get 1 over x equals 0, right? You cross multiply x over, you get 1 equals 0, and that's clearly not possible. Therefore, there is no possible x to give you a y that is equal to 0. So hopefully this is a pretty good explanation on set builder notation.